This is the second part of the video that I was shooting before. I was describing the slave part as to be connected with the master. Now, this product actually has a expansibility, with the sense that you can connect more than one slave with the particular master, and it is possible to connect multiple number of slaves. Now, the slaves can be designed according to your needs. It doesn't have to be the slave that is connected right now as we have over here. Now, let me just give you a brief of the entire slave device. It's a very a simple one, with not much complexity around its own design. The first one that I would like you to view is that both the master as well as the slave, they are based on the same microcontroller, that is the MSP430 G2553, this one, right? So that's main slave controller. Here this work of the slave is to turn a motor on or off, or a valve on or off, based on the selection that you do in the master over here, that is as I showed in my previous section. So once your device detects that the measured parameter is greater than the set point, that is your error becomes a positive. So what will be happening is that your device or your switching needs to be turned off, or your motor needs to be turned off. So that thing will be controlled by the relays which are given. So these two relays, the first two relays, are for the pump, right? So they can basically control single phase motors, and they are you can source any motor, any pump motor which has the rating of this one up to 250 volts AC with 17 amperes of peak load during the starting phase, or any 24 volt DC with a 10 ampere of starting load. Or you can also connect three valves with your slave, and these three valves will basically help you to control the water supply, where there is you have an overhead tank and you don't need a pump to be controlled for that particular reason. So it's just a basic overview of what is there you can control using this particular slave. Again, let me tell you, this is a very primitive slave that has been designed to be controlled. You can obviously design a much more complicated slaves. You can have a multi-master communication. you can use two masters or three masters to communicate in a single line. Obviously, you need to take care of many things like the arbitration control, where which master will be communicating with which slave device in case if multi-masters are trying to communicate with a single slave. So all these things we will come later on as we move into more deep into this particular device. And one thing is that you should know which there are a few LEDs which are assembly LEDs that is given over here, as you can see. So the work of these LEDs is to show you the status of the running status or any error status. So the first one is obviously the system run okay. Before that we have power. The first LED over here is the power. Then you have system run, which will be blinking when the MCU is running in normal mode. You have a valid valid data from master. So here basically you have RS485 communication. So just in case, like if any data is received from the RS485 port, so the RX LED should be blinking. But here it is implemented again in a more advanced way, that is only if a valid frame is received, you will be having this LED blink once. And then you have TX, which is for transmitting, which is not used in this particular case, but it can be that you can, as I said, that it's a very expansible device. You can design. In our website we have all the design files are there. All the files are open, so you can have your own code written, and you can also transmit some data back from the slave to the master in case if you would like to update some value in the master and send it to the IoT website. So the transmission LED option is there in case if you would need it. Right now it is functioning for two purposes. That is, suppose if your slave has been started before and if your master is then switched on, then the this start master condition will be highlighted, that is the LED will keep on, and whenever during your transmission there is an invalid data which is received where the checksum fails, or if the data is corrupted, then you will have the invalid LED lit up to make you understand that there's something wrong with the communication channel. And finally, if there is a fault in the master, then this red LED will blink. Now, what is a fault condition? Suppose if you are using this device for controlling water level, and if the pump has been turned on, and in such a case the water reservoir from where the pump is drawing water, the water level falls, then obviously you can have this emergency condition, this particular this emergency control loop to be opened. And once this emergency control loop opens up, this particular LED on the slave side will light up, and it will immediately switch off these two pump motor relays. Now let me tell you, this has no effect on the valve relays, because if there is no water, then valves won't get destroyed, but pump motor will get destroyed if it undergoes a dry run. So the fault is required for that kind of system. But again, as I said, that it's an open design architecture. You can use your own algorithm, you can use your own system technology to develop more advanced fault features, and you can display it over here. Now all the devices, they have a 2-wire JTAG system. Over here the JTAG pins are not there, but in most of the devices we do provide the JTAG pins. And in JTAG pins, as you have over here in the master, you can see there's a JTAG pin. It's a 2-wire JTAG over here. So what's the purpose of the JTAG is that like you can connect the MSP430 FET or any launch pad which you have of 2XX series, and you can seamlessly program the particular microcontroller. So this completes the basic overview of the entire system. So if you have a look at it from above, this is how it should look with the master and the slave together. On the left here is the slave, and on the right here you have the master, right? So now let me just switch on the device and show you its functionality in very small step. So that I will go on in the next video. Thank you.